Find the efficiency of joint. So previous problems which we have solved consist of a lap joint, but from now on we will be looking into a butt joint. What is the difference between lap joint and butt joint is you will be having two number of additional plates. If no cover plates are provided and only the two members or two plates is being connected, then it is called lap joint. But in terms of butt joint, you will be having additional two plates, and the plate thickness is given here 12 mm. The member or the plates which has to be connected, which is 20 mm of thickness. Now you have to find the efficiency of the joint. Provided 12 mm of plate thickness and 6 number of bolts. So totally 6 number of bolts are there. The grade what is given here is M20 grade and 4.6 grade of bolt. Then diameter of bolt is 20 mm. Since this is M20, we know that this is 20 mm. The diameter of the hole is 22 mm. The ultimate tensile strength in bearing, which is 400 MPa, and partial safety factor is 1.25. These things you have to get it from the code book. So it is available in table 5. And the plate which is having Fe410 of grade and Young's modulus. So this is E. They have written in terms of E, and it is known as Young's modulus, that is 250 Newton per mm square. So these are the given data. If you want to find efficiency, you have found out in the previous problem. Strength of joint divided by strength of plate. So you have to find the strength of joint. How will you find strength of joint? Check for bearing, check for shear strength. Then this is for bolt. For bolt you have to do check for bearing and check for shear. For plate you have to do what? Check for bearing. So these three things you have to find. All the three things have the formula. If you want to find the strength of the bolt, you have to find the strength of the joint. You have to find these three components, and what is least of these three, you have to take it as the joint efficiency. Why? Because if you are not providing any joint here, if two plates are not there, if only one plate is there, then the member force, whatever the member is there, whatever the plate is there, the bearing capacity will take care of everything. Since you are joining two plates, what happens? There might be some decrease or increase of efficiency. See, this is a whole beam. Imagine that you are cutting this as two beams and you are connecting at the center. Then what will happen? If you are not planning or not designing the joint properly, the force will not be transferred. See, if 100 kilonewton is occurring here, it has to transfer all the 100 kilonewton to the extreme end. That is called a 100% efficient connection. If efficiency is reducing, what happens? If 100 Newton is there, it will only transfer 70 Newton. Why? Because due to joint inefficiency, this might happen. So whenever you are designing any joint, you should make sure that 100% efficiency is there. You have been given a problem that you should check the efficiency. What is the force which is acting here? There is a tensile force which is acting. You should make sure that this joint component gives 100% efficiency. You can redesign that. First you have to check that this joint is capable of producing 100% efficiency. If not, you have to do that. For that, first check the efficiency, how much it is providing. So how to find that? You have to check for three types. So first thing what we will be doing is strength of plate in the joint. So take down first criteria. You are finding the strength of the plate. You have two components here. One is plate and another one is bolt. You have to check for the two components. First we are checking for the strength of plate. 6.3. You write the title as class 6.3, and what is the page number? 35. Whenever you write any title, do not forget to write these two components. So for strength of plates, these two components. Then what is the formula here? 0.9 AN FU divided by gamma ML. Okay, what is AN? Which is net area. How to find net area? B minus N into Dn. What is B? Thickness of the plate is 20 mm and B is breadth of the plate, which is given as 180 mm. The plates are provided with 180 mm of breadth. So this is 180 mm and it is given in the data. If not there, you can add it. And do you have any staggering like this? What do you mean by staggering? So a zigzag kind of a placement of bolt is known as staggering. Do you have this kind of bolt? No, you are having a straight line, hence this component will become 0. If any zigzag kind, that is staggering kind is there, then this component will come. Since this is not there, this will be 0 and B is 180. What is N? N is number of bolt. How many bolts are here? 3 number of bolt and totally 6. Plates of 12 mm size and 6 number of bolts. So totally you have 6 number of bolt. Okay. Now what are the things you have known? TH is diameter of the hole. So what is diameter of the hole? Since this is M20 grade, what should be the dia of hole? 22. Net effective area of the members. So this component will become 0. Double 280 is the net area of your section. So you found out AN. AN is known to you 2280. See here, this is for strength of plates and your thickness of thinner plate is 20 mm. Okay. So what is your answer here? 673.056 kilonewton. This is design strength of the plate. Now plate component is over, then you have to find design of bearing strength of bolt. So you have second component called bolt. So this class you write it here, along with this you write the class 10.3.4 bearing capacity of the bolt, 2.5 into KB DTFU. What is K? You have 3 component, edge distance, P is known as pitch. See, all the components are here. So what is the page number? Check in code book 75. So you write it here along the title and you check this page. E is known as end and P is known as pitch distance. FUB divided by FU. 20 mm dia hole. What is the minimum edge distance? 1.5 times the diameter of the bolt. 30. So this is the minimum edge distance. You can take it and diameter of the hole is 22. 0.4545. Yes. Next. Find the P divided by D naught into 3 minus 0.25. Now for pitch. What is the minimum distance of a pitch? 2.5 times nominal dia. Then 2.5 into 20. Here in this problem they have taken 60. So more than 50 you can take it. Here it is considered as 60. 60 divided by 3 into 22 minus 0.25. 0.6591. Yes. Next, what is the third case? FUB. They have given a grade of 4.6. So how to find the ultimate stress? 4 stands for what? 4 into 100. 4 into 100 is 400. That is your ultimate strength. They will only give the bolt grade. If they have given 5.6 grade, you have to take what? 5 into 100. That is 500. Here it is given as 4.6 grade and which is 400. And divided by FU. FU is ultimate tensile strength of plate. In the given data they have given as 410. So you divide that, you will be getting one answer 0.9756 and last answer is 1. You have to take least of that. What is least? 0.4545. Now you substitute it as KB. D is known to you. What is D? Diameter of the hole. which is 22. What is T? T is the thickness of the connected plate, and Fu is ultimate strength of the bolt. Yes. Here you have all the components here. You will be getting 186 into 10 power 3 Newton. You have to divide it by gamma MB, that is material safety. Here you have found the nominal bearing strength of bolt. After getting that, divided by gamma MB. So what is the answer? Gamma MB is 1.25. Since you are designing a bolt, that is material strength, in that you have 1.25. So you can divide these two components. You will be getting 149 into 10 power 3 Newton. Now for single bolt you got 149 Newton, that is 149 into 10 power 3 Newton. How many bolts you have provided? 6 number of bolt, so you multiply with the 6. 894 into 10 power 3 Newton. You can write it in kilonewton, 894. See, you got one answer as 894, yes, 673. Okay, now let us find the next component, that is strength of bolt. Finding the third component is strength of bolt. What is the class for this? 10.3.3. You have the formulas. 2 is ultimate strength of bolt, which is given as 400, and number of shear planes are 1. See, here you will be having 1 or 2 number of planes. How many plates are there? 3 number of plates, that is top and bottom. You will be having the connecting plate. Hence you are having 3 number of plates. In this point you will be getting a different one. You check that in the previous problem you would have got 0 as the another component, but in this problem 6 number of bolt you have to substitute here. And what is ANB is 0.78 pi d square divided by 4, which is 245, and what is SB is Shank area of the bolt, which is net area of the bolt. You have two difference. Shank area of the bolt is 0.78 pi d square by 4. Net area of the bolt is this one, and Shank area is 314. So I will show you the difference. This is a bolt. This is the shank part. You are having 3 number of plates. So one plate will be here, and another plate will be at center, and the third plate will be at nearing the edge. If you are having that, anyhow the plates will be connecting at both shank and thread of the part. What do you mean by shank is, if you have 20 mm diameter bolt, whole complete 20 mm dia bolt is there to take the load. But in terms of thread area, you have this cut, yes or no? So this thread will be 1 mm or 1.5 mm like that. So you are reducing that area. So your diameter of the bolt will be much lesser. So this thread part will not be taking the load. So hence this diameter is reduced. The shank part diameter is absolute. That is why ASB, area of shank of the bolt. That is why if it is 20 mm dia bolt, how to find the area? Pi into 20 square divided by 4. But for the thread area, what component they are adding? 0.78. Why they are adding 0.78? Due to the reduction in the thread. The diameter of the bolt is reduced. That is why they are multiplying 0.78. So that is why you have 2 number of area, which is SB. What is ASB is nominal plane shank area of the bolt, and net shear area of the bolt at thread. So do you have the two key words? So this is the shank and this is the thread. So these are the two keywords. Hence you will be finding these two area, and number of bolt remains the same, and you will be substituting 6 and 6 here. What is your answer for this? 774. You will be finding this nominal shear capacity and divided by the factor of safety. What is that? 1.25. You will be getting 619. Okay, design strength in bearing is 894 and design shear strength is 619. So which is the least? 619 is the least. So the strength of the bolt you will be taking it as 619. What was the design strength of plate? 673. So all the values you have substituted here, you will be taking the least. Okay. Now how to find the efficiency? You know that the formula is area of the solid plate. How to find area of solid plate? You have 180 mm as the breadth, and what is the thickness of the plate? 20 mm. So 180 into 20 will give the area, and you have to multiply with Fy. What is Fy? Which is yield strength. Yield strength of the plate which is given in the data. E. So what is the E they have given there? 250 divided by 1.1. So this will be the strength of plate, and the least strength of the connection is 619. Here your efficiency is 75.76%. If any 100 kilonewton is applied in the plate, how much force will be properly transferring? 75% is only the capability. You check that lap joint, the same problem you have done for check for efficiency of a lap joint. When you provide two number of plates, that is top and bottom, your efficiency gets increased. So that is why certain type of joints, how you are connecting the plate, that depends upon the joint. All the connection of rails are known as railway track. There you will be providing a fish plate, yes or no? Two rails has to be joined. There they are providing lap joint or butt joint? Butt joint. Why they are providing that? Because you have higher efficiency. Joint, each and every type of joint have their own efficiency. You can connect the railway track by this component also. You check that some rails are being cutted at the rail and they will be providing a lap joint. Lap joint also possible in the rails. They will connect the plate at the end and they will make the lap. That kind of possibility is also there. You can provide a fish plate and provide the butt kind of joint. Number of joints are there. You can find the joint efficiency of whatever joint which you have given. In your syllabus only two number of joint is being given, but number of types of connection is more. If you know these two steps, then you can find efficiency of whatever joint you are making. Design a lap joint between two plates, each with 120 mm. Now your plate width is being given as 120 mm. If thickness of one plate is 16 mm and another plate is 12 mm. So you have two different plate. Thickness, the joint has to transfer 160 kilonewton of load. The plates are 410 grade. Use bearing type bolt. If you want to provide design for shear and design for bearing, you are substituting this component. FUB is given in the data, which is 400 Newton per mm square. 1 into 0 plus 0.78 into pi d square by 4. What is your diameter? 16 square. And if you multiply this, you will be getting 36 into 10 power 3 Newton. And if you want to find design strength, 36 into 10 power 3 divided by 1.25, you will be getting 28.97 kilonewton. Now first component is over. Next component is nominal bearing strength. You know this formula, and how to find KB? KB is the least of the four components. What are the four components? First one is E divided by 2 into D naught. See, since you are designing the bolt, what is the minimum edge distance and maximum edge distance? What is the formula? 1.5 into D naught. What is the answer? 27. So you can start from 30. You can take a round off value. Why? Because this is minimum. You are getting 27 is minimum. You cannot go lesser than 27. You can go more than 27. You take a round off value, which is 30. What is maximum edge distance? You have in code book. Maximum edge distance is 12T into epsilon. What is epsilon? 250 divided by Fy. So Fy for your bolt is U is ultimate, Y is yield. You will be getting 240. Yield strength of a bolt is 400 into 0.6 is how much? 240. You substitute root 250 into 240. 1. You will be getting around 1. So you multiply 12T. What is 12T? T is thickness. What is your least thickness? You have two members. Two thickness are here. 12 is your least thickness. 12 into 12 is how much? 144. So the edge for your member might be from 27 to 144. 27 is the minimum range, 144 is the maximum range. So you can place any edge for your member. In this problem, so what is the edge we have provided? 30 mm. 30 mm is within the range. Okay. Now, what is the pitch minimum and maximum distance? Yes, pitch maximum distance is either it is a tensile force or compression force. What force is acting in your component, which is tensile? Hence, you have to use 16T. 16 into 12, 192. Up to 192, you can take it. You can provide below 192. That is the maximum pitch distance. Pitch distance, minimum pitch, you have in code book. 2.5 times the nominal dia. Edge distance, this is pitch distance and this is gauge distance. Nominal bearing strength. 2.5, what is the formula? 2.5 kb. What is kb? Kb is, what is your least of the kb? 0.49 will be the least. 0.49. Edge distance E divided by 2 into D naught, which is the cases like that, least value is 0.49. What are your values? What are your answers? You tell me. E divided by 2 D naught, what is your answer? 0.55, and P divided by 2 into D naught, for that 0.49. Then third case is 400 divided by 410. What is your answer? 0.95, and last is 1. So within that all the cases your least is 0.4907. Diameter of the bolt is 16 and thickness is taken as 12. You have two thickness of plate, which is 16 mm and 12 mm. You should take only the least plate. Why? Because that is critical, that will fail first. Hence 12 is taken. What is Fu? Ultimate strength is 400. You multiply, you will be getting one answer. 94.22 kilonewton. And if you need design bearing strength, divide by 1.25. You will be getting 75.37 kilonewton. The design strength is least of shear strength and bearing strength. What is the shear strength value? 28.9 is the shearing strength. What is the bearing strength? 75, which is least between these two? 28. So the design strength of bolt is 28.89 kilonewton. Now this is your design strength. Then the force can be transferred, a design force of 160. A single bolt can carry 28.9 kilonewton of force. So how many bolts are required if 160 kilonewton is applied? How will you find it? 160 divided by 28.9. 5.5. You round off, how many bolts will come? 6 bolts are required. Hence, your design is over. You will be providing 6 number of bolt for a edge distance of 30 and pitch of 40. Minimum pitch, which is 2.5 times into 16. 40 mm you will be getting. Minimum edge distance is 1.5 times 18, which is 27. So above that, a round off value is taken as 30. Pitch is taken as 40. Yes, all the values you know here. Check for the strength of the plate. The plate strength is 0.9 into AN. What is AN is net area. So how many bolt you are providing? 2 number of bolt in the net. If you are taking this cross section, 2 number of bolt is taken. Hence you can subtract this 2 number of bolt. 120 minus, this is the breadth, minus 2 into 18. 18 is diameter of the hole, and into 12. So this is breadth and the thickness. You will be getting the area into FU is 410 divided by 1.25. You will be getting 297.52 as the force which is coming in the plate. And what is the applied force which is here? 160 kilonewton, lesser than the strength of the plate. So 297 is the strength of the plate. So your design is safe.